All right, so we are going to start 2.2 definitions and biconditional statements today. If you remember, when we started talking about our systematic approach to doing geometry, we started with we started with undefined terms, okay? Things like a point, line, plane, they're undefined. We just had to give them basically a definition, but but now, when we start doing definitions, a true definition, we're using known words to describe new words. And so, for example, perpendicular, we're going to use some known words to describe what perpendicular means. Okay, so perpendicular lines, they intersect to form a right angle. Okay, so perpendicular lines, they intersect to form a right angle, and as you can see in this notation, a little square in the corner is the symbol we use to show lines are perpendicular. We can also have a line that's perpendicular to a plane, so this line is going to be perpendicular to that plane, and a line is perpendicular to a plane if this line is going to be perpendicular to every line in the plane. So if I draw kind of a line in here, if this line is in the plane and this line is perpendicular to that line, then this line N is perpendicular to plane P. Okay. Symbolic notation, the notation, like in example 1, if we wanted to write this out, we're going to say line N is perpendicular to line M. Sorry about that handwriting. It's line N is perpendicular to line M. So the symbolic notation, this represents perpendicular. It's kind of that upside down capital T. Okay. The other part of the section is on biconditional statements, if and only if statements. So a biconditional statement is written where you have if this happens and only if this happens, then you conclude this. So basically, what it's saying is if it's true forwards, it's also going to be true backwards, and if that backwards would be like the converse. The converse is true of the statement. So let's talk about an example, since it's kind of confusing till you see it. 3 lines are coplanar if and only if they lie in the same plane. So first, this is a biconditional statement. Biconditional means it works both ways. It works this way and it works that way. So it works as you read it left to right, but also if I read it backwards, 3 lines lie in the same plane if they are coplanar. If and only if they are coplanar. It works the other direction. So we can take a biconditional statement and rewrite it into a conditional statement. And I think I already pretty much said that. So a conditional statement is that if-then statement. If this, then we can conclude what? So if 3 lines, and if you want to abbreviate things like the go for it. It's not necessarily English class, but we want to make sure you know the definitions here. If 3 lines are coplanar, now coplanar, let me clean up my handwriting a little bit. If they are coplanar, then they lie in the same plane. That is the conditional statement. The converse, remember, converse is when you flip the order. And so we'll say if 3 lines, okay, that's the they. You want to say they lie in the same plane. What's they? So we say if the 3 lines lie in the same plane, then they are coplanar. Okay, so remember, coplanar means in the same plane. So it makes sense, I think, to have this be a biconditional, that it works both ways. You know, if they're coplanar, then they're in the same plane. It's kind of by definition of what coplanar means. So let's do an example here. Each of the following statements are true. If the converse of the statements are true, combine them to form a true biconditional statement. If the converse is false, state a counterexample. So we want to see if these statements are true. So we have an if-then statement. If 2 points lie in this plane, then the line containing them lies in the plane. So we look at this. Each of the following statements is true. So this is a true if-then statement. Okay, if the converse of the statements are true, we're going to write a biconditional statement. Okay, so is the converse true? The converse would be, you start with your conclusion, if the line containing 2 points, remember them refers to the 2 points, so if a line containing 2 points lies in the plane, then the 2 points lie in a plane. Is that true? So if you need to, you can write that out. If two points lie, if the line containing 2 points lie in a plane, then 2 points lie in the plane. That seems to make sense to me, so I'm going to say the converse is true. And now we're going to combine them to form a biconditional statement. So here, to write my biconditional statement, I'm going to say 2 points lie in a plane. Now here is the part where, so I took out the if, and I'm going to take out the then, and the biconditional part is 2 points lie in a plane if and only if 2 points lie in a plane if and only if. And now I can do the conclusion part. If and only if the line containing them lies in the plane. Okay, so there's number one. Number two, if a number ends in a 0, then the number is divisible by 5. So you can ask yourself, does that one make sense? You know, if you read the directions, each of the following statements are true, this should be a true statement, okay? But now, does it make sense? The number ends in 0. So they're talking about if the number ends in 0, like 10, then it is divisible by 5, and that's true. Well, what about 20? Yep, that's true. 100, yep. So, okay, that first statement is true. Is the converse necessarily true? So we got to think about what the converse is. Okay, so think about the converse. I'm gonna kind of switch the ifs and the thens. So if the number is divisible by 5, then it ends in 0. So if a number is divisible by 5, then it ends in 0. So I'm going to pick a number that's divisible by 5. For example, 25 is divisible by 5, correct? If the number is divisible by 5. Okay, so that part is satisfied. My hypothesis is satisfied. It's the conclusion part, the then part. Then a number ends in 0. Well, does my number 25 ends in 0? No. So my counterexample is 25 is divisible by 5, but does not end in 0. Okay, that's my counterexample. So the biconditional statement is not true, but this original statement was. Okay, one last example here. Consider the following statement: x squared is less than 49 if and only if x is less than 7. Is this a biconditional statement? That's the first question. If and only if. So x squared is less than 49 if and only if x is less than 7. So yes, it is a biconditional statement. Now the question is it a statement true? So we can write a biconditional statement and it does not necessarily mean it's true. That's something that you would want to prove. And one way to prove, it's easy to prove something's not true. So I could prove it's not true with a counter example, like we did in the last example there. And I'm going to look at this if x squared is less than 49, if and only if x is less than 7. So I look at this, if x is less, what if x was 6? Well, 6 squared is less than 49. Okay, and I could keep going. But at some point, can I put in some value for x to make it not true? Okay, so I want you to think about that. Remember, it has to work both ways. And so I could pick values of x to make this part true, and it would have to fit into here, or vice versa. And I'm thinking, well, what if I picked a negative number? Okay, like a -3. Well, -3 squared is 9. That's less than that. That's less than that. That works. So, oh, shoot, that didn't work. So, try your integers. If they don't work, you can try, I should say whole numbers. If they don't work, try your integers, which would be negative numbers. You might have to pick different sizes. You could pick fractions to look for a counterexample. And in this case, I'm going to pick a number now that is greater, the absolute value of the number is greater than 7. So like a -8. What if I pick -8? Okay. A -8 is less than 7. So if I broke this into a if-then statement, if x is less than 7, -8 is less than 7, then is x squared less than 49? Well, -8 squared is 64, so that part wouldn't be true. So I could say, is the statement true? It is not. Not true, or you could say false. It's not true in all cases. Okay. And there's a look at your homework coming up. Notice we're omitting skip 8 and 36. And you'll get time to work on that in class tomorrow. So have a good night.